What's up, Geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 4.1, reflections. So we're going to be able to use rigid motions to reflect figures on the coordinate plane and describe the effects of those reflections. We've got some vocabulary terms and pictures that we're going to talk about. So let's first talk about rigid transformation. And that essentially is when you take a shape and you move it using a transformation, and it's not going to change the size or the shape of the figure. So the definition would be a geometric movement that preserves a figure's size and shape. The next one is called a pre-image and an image. So pre-image, and I'm going to use a reflection example here, and then the image. So starting with the pre-image, this is when you have your original figure before a transformation. The image is going to be a new figure that results from the transformation. Okay, so in this picture we have the pre-image, which is this normal ABC. And then we have the image, which is the A prime, B prime, and C prime. So make sure you note that whenever we're talking about lettering, the pre-image is a normal letter, whereas the image has a letter with a little prime symbol, and you would call this A prime. Reflection is what we're going to focus on today, and that is a rigid transformation that flips a shape over a line. So we're going to go ahead and draw a picture. Pretend that was a straight line of a triangle ABC, and really just repeat what we had for pre-image and image. So here's my pre-image, and then my reflection would have C prime, A prime, and B prime. Okay. The line of reflection is the line in which a shape is reflected over. So here would be my line of reflection. So make sure we got our definitions and pictures drawn, and then when we're ready, let's go ahead and try example 1. So example 1, we're going to reflect triangle ABC with these vertices of 4, 6, 1, 2, and 0, 3 about the x-axis. So we first wanted to make sure we understand here is the x-axis. So this line is going to be my line of reflection. I'm trying to draw a straight line as much as I can. So A prime, what I'm going to do is I'm going to count the distance from this point to my line of reflection. So I'm 1, 2, 3, 4, 5, 6 steps away. So that means I'm also going to be 6 steps away on the other side. 1, 2, 3, 4, 5, 6. And then plot my A prime here. That image was going to be at 4, -6. So B is 2 steps away from my line of reflection. So I'm going to be 2 steps on the other side. Label that B prime. That is now 1, -2. And then C prime, if I'm 3 steps away from the x-axis, I will be 3 steps away on the other side. So C prime is now at 0, -3. And then we're going to connect our dots here, our points, and now we have our reflected image. One thing I want you to think about is something changed with my y coordinates. So when you do an x-axis reflection, the y coordinates change. And specifically, they change to their opposites. Okay? So something to think about as we're talking about rules. For example 2, reflecting triangle ABC with vertices, again, 4, 6, 1, 2, and 0, 3. Now we're going to try that about the y-axis. So here's my y-axis. Again, try my best to label that well. So A prime is now 4 steps away. 1, 2, 3, 4 from the y-axis. That'd be 1, 2, 3, 4 on the other side. And that new point is -4, 6. So again, notice that I was at 4, 6, and now I've changed to -4, 6. Point B is at 1, 2, so I'm 1 step away from the y-axis. That means I'd be 1 step away from the other side. So now I am at -1, 2. Again, just that x value is changing. And then C is actually on the y-axis, so it will not change at all because it's 0 steps away from the y-axis, so I'd be 0 steps away on my reflection. As I connect my points, I should notice a y-axis reflection of triangle ABC, and then C's point would still be remaining 0, 3. So when I have a reflection across the y-axis, I'm going to change x coordinates to their opposites. Okay? Now we're actually going to be given a new line. So this one says reflect quadrilateral math with these vertices across when x is equal to 1. So now we're going to look at the x-axis, but we want x being equal to 1. So here's my x being equal to 1. So my line of reflection is here. So now instead of this being a reflection across the y or the x-axis, it's now across a point on the x-axis. Because I'm going x is equal to 1, now I'm just counting away how far away each letter is from that line of reflection. So letter M is 1 step away from the line of reflection, so I would be 1 step away on the other side. So M prime is 0, 4. Notice that my 2 changed to a 0. Now I'm ready for A. A is 1, 2, 3, 4 steps away, so I'm going to be 1, 2, 3, 4 steps away on the other side. Now I'm at -3, 4. I changed from a 5 to a -3. Now I'm at T. T is 1, 2, 3, 4 steps away, so on the same line, 1, 2, 3, 4. Here's my T prime. And I'm at -3, 3. And then H is 1 step away from the line of reflection, so I'll be 1 step away on the other side. So H prime is now 0, 1. And then you connect M to A to T, T to H, and H back to M. You could also connect your points as you go to create your figure. Example 4 is now going to be y is equal to -1. So if we find our y-axis and the -1 on my y-axis, here is going to be my line of reflection. Again, trying hard to get that straighter line. You probably could do a better job on your paper. So starting with letter M, M is 1, 2, 3, 4, 5 steps away from the line of reflection. So I'll go 1, 2, 3, 4, 5 steps away on the other side for M prime. M prime is now sitting at 2, -6. Notice that just my y value changed here. Letter A is next. Letter A is also 1, 2, 3, 4, 5 away. So 1, 2, 3, 4, 5 on the other side. And I'm going to go ahead and start connecting as I go. This new point for A prime is 5, -6. T is here, and that's 1, 2, 3, 4 away. So 1, 2, 3, 4 away from the other side, T prime. connect that to A prime. T prime is at 5, negative 5. And then H prime is 1. H is 2 steps away, so H prime would be 2 steps away on the other side. And then that is 2, negative 3. So only my y values changed here, connecting point T to H and H back to M. Okay, so there's my line of reflection over the y point of negative 1. Now we're going to look at reflecting about when y is equal to x. So when y is equal to x is technically not a vertical or a horizontal line. It's going to end up being a diagonal line. That just says I need my line to be through the origin going up by a slope of 1. So here is my line of reflection, and again I'm trying to do that the best I can. Okay, so that means this entire shape is just going to flip down into this area. So one thing that's going to happen, let's say we start with point Q. Point Q would be down 1 over 2, so it'd be down 1 over 2, and it's going to end up here as our reflection. Here's why. Q is currently at negative 2, 1, and anytime we reflect y is equal to x, our rule says this. I'm going to take my xy coordinates and I'm going to flip them to be y, x. This is also going to be thinking about if you cut your paper in half, you should have those figures reflected on each other. So Q prime is going to be 1, negative 2. So 1, negative 2 is going to end up here. Okay, I'm going to do the same thing for R prime. Right now, R is at negative 1, positive 3, so my image would be 3, negative 1. So to the right 3 and down 1. Here's my R prime. Go ahead and connect Q to R. Next is S. S is currently at 1, 5, so S prime would be 5, 1 over 5 up 1. S prime, connect it. T is currently at 1, 4, so T prime, flip them around, 4, 1, right here. Go ahead and connect S to T. And then U is 3, 4, so U prime is 4, 3 over 4 up 3, and there's my reflection. So notice that U is closest to U, and then we're going to connect all the way back to Q. So we can fold our paper, and for the most part, we've got them lying on top of one another. Our last example, and this should say example 6 in your notes, reflect the following figure about the line y is equal to negative x. This one is a little bit different because y is equal to negative x is not going to be a positive slope. Instead, it's going to be a negative slope. So here is my line of reflection. And right now, Q is at negative 2, 1. So my image of that, I'm going to flip these around and make them their opposites. So when y is equal to negative x, my rule is this. I'll have x, y, and then it'll flip it around to be negative y, negative x. So if it's positive, it'll change to negative. But if it's negative, it changes to positive. So Q prime, I'm going to lead with a 1, but change 1 to its opposite, negative 1. And negative 2 would follow, but I'll change that to its opposite. So it'll end up being negative 1, 2. So negative 1, 2, and it's actually going to overlap. It'll be ending up right here for Q prime. Okay, let's go into point R. Right now, point R is 1, 6. So reversing that and making them their opposites would be negative 6, negative 1. Negative 6, negative 1 is here. There's my R prime. Go ahead and connect Q to R. Next, we have S at 1, 4. So reversing that, negative 4, negative 1. There's my S prime. T is currently at 4, 4. So flipping those would be both negatives, negative 4, negative 4. T prime. And then U is currently at 2, 2. So reversing that and flipping to their opposites, negative 2 for U prime. Okay, and there you have it. So that one overlaps on itself just a little bit, but again, it's still showing that line of reflection. So that means if we folded our paper on that line of reflection here, both those shapes will be on top of one another. That is going to be all for our notes today. Thanks so much for tuning in for 4.1 reflections. Check on us next time when we talk about some different transformations. Have a great day.